and let's move to our next speaker, who is Alexander Loesing from Allos Semiconductor, and he's going to give a talk on the development of gallium nitride micro-LEDs on 300 millimeter silicon wafers.
Thank you. Thank you, and good morning, or rather almost good afternoon, everybody, ladies and gentlemen. Thank you for the organizers to give us the opportunity to present our technology here. And we are all eager to make micro-LEDs happen. Yeah, you know all the bright examples shown at many conferences, also here today. But there are still some issues. I don't want to talk about the social acceptance, but we all know there's a lot of technical challenges we still need to address. Power consumption, system integration, RGB. Thank you for the great talks on red. That's very encouraging. We like this a lot. But there's still a lot of things. And there's also profane things like the cost and the yield we need to deal with. For the micro-LED chips. And today, these are actually not so encouraging, let's say, and causing a lot of issues in making this happen. Now, when you think about this, what are actually the requirements to do this for the micro-LEDs and to get this at high yields and also at low cost? One thing which comes to mind very quickly is you need to go to a different manufacturing system. Because today's LED manufacturing systems are not meant for these small sizes. And I personally think that at Display Week last year, you could see quite a tremendous shift in the industry belief, I would say, that we need to go to semiconductor processing lines to achieve the kind of yield levels and cost points which this industry needs. We're not talking about conventional LEDs, where you actually can accept a lot of defects on a large chip, but if you have the same kind of defect on a micro-LED, and imagine you have this in an array which fits into your glasses or into some head-up displays, that kills the complete product. So that needs to be avoided. And the nice thing is the semiconductor industry is big, powerful, successful. And as we all know, it's mainly digital. I don't want to talk about the analog products here, but it may be digital in a very different way from what we think. And that is actually the acceptance criteria. So when we think about these LEDs, and we have seen a number of talks yesterday, also in the master class, we're not talking about silicon. So it's different materials, and you need to convince these guys to get the wafers into their fabs. And today, all the nice prototypes, well, not all actually, but the majority of them I showed earlier, and the most you see are built from LEDs which are made on sapphire, which are coming from the traditional LED world. So this is happening on small diameters. It's happening on wafers which are actually fairly thick. The industry needs that to control the strain. And still the strain is so high that you get large bow, which is then for subsequent processing steps like bonding, a problem for yield, which then is causing higher cost. Now, the silicon industry is very digital about. They cannot work with this. Now, what you need to do is you need to go to the wafer sizes they're used to, which is 200 and 300 millimeter diameter. You need to have the wafers in the same physical dimensions. So the first thing is you need to have the right thickness. And there's also other aspects. For example, the edge rounding, things like this, the overall surface quality. There's a lot of things which they would simply not accept in their line. And a lot of know-how to get this right. And the last here is the bow. So ideally, you want to be at 50 micrometer. We saw yesterday in a master class that is also achieved by some people now for 200 millimeter wafers. And I'm going to show you what we have been doing here. So 200 millimeter, actually, we have been doing since 2011 at our predecessor company and at Allos in a production. So we also had 50 micrometers bow back then. I'm going to show you some values what we have now in terms of the repeatability and the overall scope we can do, how to handle this. And we can also do this on 300 millimeter. Already for several years, you may have seen the news recently from Infineon that they are now for power semiconductors also going for 300 millimeter diameter. Also stressing very much the advantages that you can utilize existing semiconductor industry equipment.